Hi Math 3 students, and welcome to your 3.8 Ed Puzzle. So, let's go ahead and get started. Let's try number 1 here. So it says, if you know that 7 is a factor of 147, what would you do to find the prime factorization of 147? Explain your answer and show your process here. All right, so basically what they did by telling you that 7 is a factor is it kind of helps you out. It tells you where to start. Remember, like when we were trying to find factors, you kind of just have to try numbers until they work. In this case, they gave you a number that you know was going to work, and you can go ahead and use that to find the prime factorization. All right, so for this one here, we would break 147 down into 7 and 21. How did I get that? Well, since I know that 7's a factor, I could do 147 divided by 7, right? And then I, of course, can break 21 down further, which is going to give me a 7 and a 3. And now I've got all prime numbers. I've got my prime factorization, all right? So then how would you show your answer? Well, when you're doing prime factorization, you show all the prime numbers that multiply to give you that number. So we would have 3 times 7 times 7. All right, and that would be our prime factorization. So for number 2, it says, how is your answer like a polynomial written in the form x minus 7 squared, x minus 3? All right, so what that shows here, and I guess actually we can go back to 1, we could also write this as 3 times 7 squared. Keep that in mind. How are they similar? Well, essentially you're just showing that when you multiply the factors, all the factors, that is equivalent to what you started with, right? So basically it's just showing that you need to multiply the factors to get, I guess it would be like original equation. All right. Next it says, the process for finding factors of polynomials is exactly like the process for finding factors of numbers. We start by dividing a factor we know and keep dividing until we have all the factors. When we get the polynomial broken down into, excuse me, goodness, it's early, you can tell it's 7 in the morning here. When we get the polynomial broken down to a quadratic, sometimes we can factor it by inspection, and sometimes we can use other quadratic tools like the quadratic formula. Let's try it. For each of the following functions, you have been given one factor. Use that factor to find the remaining factors, the roots of the function, and write the function in factored form. So basically, think about what we did here, right? We were given a factor, so we divided that out from the main guy, and then we were left with this 21, and then we factored that further. So that's exactly what we're going to do here, okay? I'm definitely going to need to make a small thing here. All right. So they gave us that a factor is x plus 3. So you know what we're going to do is we're going to go ahead and divide that in here. So our long division's coming back here. All right. And we're going to do x cubed divided by x. We get x squared. So then we're going to get x cubed plus 3x squared. Change our signs. We get 0. All right, we bring down our negative 4x. So if we do 0x squared divided by x, we get 0x. So then we'll go ahead, we'll do our subtraction of 0 here. We end up with negative 4x, bring down our negative 12. And we do our division, so negative 4x divided by x is going to give us a negative 4. So we're going to do negative 4x minus 12, change the signs, and we get 0 as our remainder. Now keep in mind, you should be getting 0 as a remainder if it's a factor, right? If it is not a factor, then you get a remainder. So on any of these problems, if you do get a remainder, that means you probably did it wrong since they told you that it was a factor. All right. So here we've got our answer, which is x squared plus 4. Oh, minus 4, sorry. All right. So now we actually can factor this further. If you guys remember difference of squares, or you can even think about, like what multiplies to give you a -4 adds to 0. But this is a difference of squares here. So you take the square root of both, you get x plus 2, x minus 2. So we can factor that further. So basically now we know that this guy times this guy is going to give us this guy, right? So we've actually got our factored form here. It's going to be x plus 3, x plus 2, x minus 2, all right? Then they want to know the roots of the function. So we get the roots of the function by setting the factored form equal to 0. So the roots here are going to be -3, -2, and +2. So what I did is, remember it was like x minus your root, so the sign has to change. Another way to do that is just set these equal to 0, right? You'd bring that over, and that's how you'd get like your -3, okay? So that is what we're doing here. They give us the factor, we divide it in, then we take our answer here and we try and factor that further. So let's go ahead and try another one here. So we got number 4. So they gave us our factor of x plus 1, x plus 1, x cubed plus 6x squared plus 11x plus 6. So we'll go ahead and divide it in there. I do x cubed divided by x. We get x squared. We do our multiplication. We get x cubed plus x squared. Change the signs. And we get 5x squared. Bring down the 11x. 5x squared divided by x is going to give us a 5x. So we'll go ahead. We get 5x squared plus 5x. Change our sign. Going to give us a 6x. Bring down our 6. We're going to do plus 6. So we can go ahead and multiply. So we get 6x plus 6. Then we got to change our signs. And we get 0 as a remainder. All right. So basically what this means is that this times this is going to give us our function. So let's write that down at least. All right. So what we're going to want to do here is see if we can factor that further. Now, sometimes you're going to be able to factor. Like this one, we were able to just kind of factor that in our heads here, right? This one you should also be able to factor in your head. You're always going to want to figure out what multiplies to give you that guy, adds to give you this guy, right? So if you factor that further, you get x plus 2, x plus 3. 2 and 3 multiply to give you 6, add to give you 5. So that would be our factored form. I guess I could just copy paste it, right? And then our roots, right, we get from setting these equal to 0 and solving. So it'd be x plus 1 equals 0 is going to give us a -1. X plus 2 equals 0. We get a -2 and so on. So we got -1, -2, and -3 as our roots there. All right, let's try number 5. So we're going to go ahead, again, do our division. X cubed divided by x is going to give us an x squared. Get x cubed minus 5x squared. We change our signs. We get 0. Bring down the -3x. So again, we're going to do a plus 0x in there. We get a 0, 0. Do our subtraction. We get a -3x. Bring down our 5. -3x divided by x gives us a -3. So we get -3x plus, oh, there's a 15. I was like, something's not right here. There you go, plus 15. And then we change our signs. We get a 0. All right, so that means that we did it right. And our two factors here are x minus 5 and x squared minus 3. Now there's two ways you could go about factoring this guy further, or like actually finding the roots from him. One way is to use quadratic formula, right? You'd have that a equals 1, b equals 0, and c equals -3. You could use quadratic formula, but personally, oops, thought I was erasing. I would go ahead and set this factor equal to 0. So you get x squared minus 3 equals 0, plus 3 x squared equals 3, plus minus x equals plus minus root 3. All right. So then your factors here, now that you got your roots, right, we got all of our roots, which are going to be 5, root 3, and minus root 3. So then the factored form is going to be x minus 5, x plus root 3, and x minus root 3. Now, one thing I want to point out up here, let's see, where was it? I used like the difference of squares to solve. You could have also used that method of setting it equal to 0. So we had x squared minus 4 equals 0. So you'd have x squared equals 4. X equals plus minus root 4, which is going to give us plus minus 2, which is what we got here, right? We got roots of positive 2 and negative 2. So that's another way you can do it. So there's a lot of different methods we can use to factor these. At the end, we'll do kind of a summary of all the different methods. And unfortunately, I can't just tell you which method's going to work. I guess I will say that quadratic formula always works, but it's not always the quickest. So for all of these, you could have used quadratic formula on your answer piece up here. Like you could have plugged this into the quadratic formula. You could have plugged this in. You could have plugged this in. That would have worked. But this is just a little bit quicker if you're able to factor in your head. All right. Now, for some of them, you're only going to be able to use quadratic formula. There's really no other option. So let's go ahead and try number 6. So our factor is x minus 3. We get x cubed plus 3x squared minus 12x minus 18. So we're going to do x cubed divided by x. We get x squared. We'll go ahead and multiply. We get x cubed minus 3x squared. Change the sign. And we get 6x squared. All right. Then we're going to go ahead and do our division here. So we get 6x squared divided by x. We get plus 6x. Do our multiplication. Oh, and I forgot to bring down my 12 here. So we get 6x squared minus 18x. So we'll go ahead and change our signs. So we get 6x, bring down the 18. 6x divided by x is going to give us a 6. So then we multiply, we get 6x minus 18, change our sign, we get a remainder of 0, which is good. That's what we wanted. So now we've got this guy. So far, the two methods we've used is setting equal to 0 and factoring, right? So for this guy, setting equal to 0 is not going to work because you have that middle b term. When you have that, your other option's factoring. And unfortunately, this is not factorable. There's no two numbers that are going to multiply to give you a 6 and add to give you a 6. That just doesn't exist. So our last option here is to use the quadratic formula. All right. So let's go ahead and use quadratic formula here. So we're using it on x squared plus 6x plus 6. So we're going to do negative b, which is 6, plus or minus the square root of b squared, right? So this is our b. So it's going to be 36 minus 4 times 1, 4 times a, which is 1, times c, which is 6, divided by 2a. So I guess here I'll write out which one it was. A equals 1, b equals 6, and c equals 6. And then it's all over 2a, which is going to be 2. So then to simplify this, we're going to have negative 6 plus or minus the square root, and then 36 minus, let's see, 24 is going to give us 12. Yes, 12. So root 12 over 2. And then we have to simplify this further, right? So to break down a 12, we're going to get negative 6 plus or minus, and we can pull a, so for 12, we get 4 times 3, so we can pull that 4 out, and it becomes a 2. So we get negative 6 plus or minus 2 root 3 all over 2. Now, again, we can go ahead and simplify this a little bit further here. So when we do that, we take out a 2 out in front. So we would get 3 plus or minus root 3, and this was all over 2. All right. So now that we've factored the 2 out of both terms, we can cancel, not erase, let's cancel them. All right. And the roots here, see, I kind of ran out of space. Let's make this nice and tiny so I got some space here. My roots are going to be, this guy set equal to 0, so dx minus 3 equals 0. We get x equals 3, so we got a root of 3. And then we also have negative 3 plus root 3 and negative 3 minus root 3. And that came from, splitting this guy apart because we got negative 3 plus minus root 3 left over. All right. So that's how you get the roots. Now, to put that in factored form, we're going to do x minus 3. And then we got to do minus our roots, right? So we do x minus negative 3 plus root 3 and x minus negative 3 minus root 3. So this isn't really how you'd want to leave this. You'd want to write this a little bit nicer. So the way that I would write this, I'll zoom in a little bit, would be x minus 3. And then you would distribute this negative. So you get x plus 3 minus root 3 and x plus 3 plus root 3. All right. And this is how you would want to write that in factored form. A little less pretty than the other ones, but still doable, right? All right, so let's go ahead and try number 7. All right. Now there is multiple ways to do number 7. You could go through and try and divide this in there, but there is an easier way. Looking here, we've got a perfect square. Now, how do I know it's a perfect square? Or I should say it's a difference of squares. We have a subtraction sign surrounded by 2 perfect squares. So that tells us we have a difference of squares. And just to remind you guys, this is kind of like just an addition, right? If you have something that's squared minus something that's squared when you factor it, you have to take the square root of both. So you would get a minus b and a plus b, right? The square root of a squared is a, square root of b squared is b. And that's kind of the factoring pattern there. So we're going to use that here. So the square root of x to the 4th is x squared, and the square root of 16 squared is 4. All right, so when we factor that, we're going to get x squared minus 4, x squared plus 4. All right. Now, we're looking good, but we can still factor one of these further. This is another difference of squares. Hopefully you guys are good at identifying these. We can take the square root of both of these guys. We get x minus 2, x plus 2. We got this x squared plus 4 going on there. All right. So we factored this completely. We've got our 2 factors here, right? Our x minus 2, x plus 2. But with this x squared plus 4, we got to do a little bit of work. You could use quadratic formula. Go for it. But I think the easiest way would be to actually just solve. If you do x squared plus 4 equals 0, right? Remember, you can always set the factor equal to 0 to get the roots. So you do minus 4 minus 4. We get x squared equals negative 4. Take the square root of both sides. We get x equals, and then we're going to get plus minus. And then since there's a negative sign in there, we get an I. Square root of 4 is 2. So we get plus minus 2i. So our roots are going to be 2, negative 2, positive 2i, and negative 2i. All right, so the factored form of this guy is going to be x minus 2, x plus 2, x minus 2i, and x plus 2i.